Hello, this is Lab 1 for Physics 2 over charge tape. The purpose of this lab was with a model of charge tapes, we were going to measure the separation distance and use our prior knowledge of forces and electric fields to find the charge of the tape, the amount of electrons, and the excess of charge on the tape as well. And then we were going to use code to replicate the experiment. Our findings was that the positive tape has a positive charge, the top tape, and the charge of the tape is 2.38 times 10 to the negative 7 coulombs. But the tape has a deficit of 2.6 times 10 to the fifth electrons, and that checks out because the tape has a positive charge. Key concepts that we focused on in this lab was the gravitational force, which is just negative mg, because there's a force acting downwards on the top tape. And then with that, there's also the electric force, which is just the electric field times the charge. And the electric field is found by taking K, the electric constant, which is the value is given there, times the charge squared divided by r squared, which is the distance, and then r hat to give direction. And then with all of that information, we could take the magnitude of the force, which is equal to kq squared divided by d squared, the distance. And that allowed us to find the charge within this experiment. The model of this experiment is shown. The system is the top tape, and the surroundings are the bottom tape, which is held with our hands, and also the Earth. F net on the top tape, number 2, the orb there is 0. And then we have force gravity going downwards and force electric 1 onto 2 going up. And then for tape 1 on the bottom, we have force electric 2 on 1 going down, and then force from the hand going up. And within this lab, we did make some assumptions that each tape has the same net charge. The tape was treated as a point charge to simplify things. The atom is a perfect square, and then also air resistance was ignored, even though it's a moving object. Within this experiment on the left, you can see the tape and how it was charged. It was just ripped fast to create a charge, and then that tape was held up to the top tape as seen in the diagram on the right. We have the top tape situated between two items. We have a separation distance of d, which was measured as the bottom tape got closer to the top tape. So that distance was measured once the top tape just started to move even the slightest bit. Within the code on the left, we have our initial conditions, and those were just measured, or those are just constants that we've found. Um, First, we found the electric force, which we knew was just the opposite of the gravitational force in magnitude, just the negative. And then we were able to find the charge with that by rearranging some of the variables of the equation we had earlier. And then we could find the number of electrons by taking the charge of the tape, which was found, and then dividing that by the charge of the electrons to find the number of them. And then we could also find the number of atoms um, and the ratio by taking atoms divided by electrons. And finding the tape area divided by the atom area. And then we have a visualization on the right where we have gravitational force as the pink arrow going down, and then the electric force is the blue arrow going up. And then we have a couple statements that just define some of the things that we were looking for. In conclusion, the top tape is in a state of equilibrium and the net force acting on it is 0. The top tape and the bottom tape had a positive charge, and thus the tapes would repel from each other. The positive nature of the tape means that there's a deficit in electrons, which was proven through our calculations. And that's because their negative charge is not sufficient to override the positive charge of the proton. The computational model was accurate because those were the same numbers we got through just doing like typical hand calculations. And possible sources of error that could have come out of this lab was the two tapes could have not been entirely parallel during the measurement of the separation distance, which would throw off that measurement. And then the model also assumes no other outside forces than the one being analyzed. What if electrons has positive charge and protons had negative charge? What would change with the tapes and other charge objects? The tapes would have different overall charges. The positive tape would become negative and the electric field would point in the opposite direction. The observations between the tapes would not change. The two tapes would be negative and still repel from each other. The tape would still react the same way it would with other objects. And it's important another question we had was why is it important to handle the charged tapes as little as possible? What happens when they come into contact with hands and other objects? Charges can be transferred through contact, so it would impact the entire electric field that we're measuring and the overall charge of the object. Because touching the tape repeatedly causes it to gain electrons from your hand and decreases the positive charge of the tape.